topic for the last couple of weeks that we've been spending here at Full Stack. I wanted to learn more about machine learning, and in particular machine learning in JavaScript. So my background has nothing to do with, I'm not a data scientist, and I don't know much about this, but I think it's a really interesting topic, and I really want to share with you what I've learned to date in the last few weeks. So there's a definition. I'm just going to read it out. Machine learning is the idea that there are generic algorithms that can tell you something interesting about a set of data without you having to write any custom code that is specific to the data. So instead of having to write code, you feed the data to the algorithm, and it builds its own logic and based on the data. Another person, Heather Arthur, we're going to talk about it later, she defined it as machine learning is used to solve tasks that people are good at, but computers are traditionally bad at. So what does that mean? Basically, if you have any kind of solver, like just think of Excel functions, for example, you write a pretty specific function to do some task. And if you were to tell that function, okay, today I'm going to teach you, today I'm going to want you to figure out, I don't know, calculate like housing prices, and tomorrow I'm going to want you to calculate how to drive a car, that function will probably not do the second job very well. While machine learning, the idea is that you use an algorithm and you just feed it data, and it learns kind of how to interpret the data, and it sets up its own rules essentially. So some popular examples, Netflix and Amazon, and so typical kind of recommendation engines are machine learning, are made by machine learning algorithms. Things like spam filters or just kind of language detection, what's it called? I forget the word for it. Like if a phrase is positive or negative, those kind of things. On the right-hand side, you can see a pretty popular machine learning database to teach the computer computer vision. So this is called the MNIST database. There are 60,000 sets of numbers in little tiles, 28 by 28 pixels, which is important. They're all the same size. And they have numbers 0 through 9, and they have been labeled by some very nice people. And essentially, there are 60,000 of these. So once the computer went through all of them, it understands what a typical 1 might look like and what a typical 5 might look like. And the nice thing, again, about the algorithm is it can do many different things. So you might use the same algorithm more or less, not just to detect handwriting, but also to detect what kind of vehicle is driving in front of you, if you want to apply the machine learning algorithm to driving, for example. There are two kind of overarching ideas or mechanisms, I guess. One is called supervised learning, and one is called unsupervised learning. As far as supervised learning goes, we start out with a set of prepared data that it has been labeled, such as those numbers from 0 through 9, and we feed them through the algorithm, and we tell it whenever you see something that looks something like this, that's what you want it to be. So whenever there's something that looks like a 0, it should be a 0. And then the computer kind of, reads the data and kind of develops its own mind about it. While unsupervised learning is more used if we just have a bunch of data and we don't really know what it might mean or what it might tell us, and we just say, hey, can you see anything out of this data? Good luck. So for example, Netflix and Amazon are examples where Netflix just kind of figures out, based on some patterns that it can find in the data about what movies people have watched or have liked, how other people with similar kind of patterns, what those people have watched in the past. And then it can recommend to you, based on the patterns that it finds, what you might enjoy, for example. Or it might do things like find particular outliers. It might tell you, oh, your data set is typically kind of in this area, but there are some particular items you might want to look at closer. So there are a lot of different algorithms, and today we're going to look at one called artificial neural networks, or not so much look at it, we're going to use it. And also there are a ton of different libraries out there. When I type in popular machine learning library, JavaScript doesn't show up. So typically in research, R and MATLAB are used a lot. In industry, Python is used a lot. C++ also for if it has to be kind of closer to the metal. Google just open sourced a machine learning library called TensorFlow. So it's really kind of everywhere, and it's really available to all of us. But like I said, JavaScript is also kind of starting to get into this game. In particular, there's one library called Brain.js, which is a pretty easy, very easy to use neural network library created by a person called Heather Arthur. And at this point, it has more than 6,500 stars on GitHub. So it seems to be pretty popular. And there are essentially 3 lines of code, like one line to just create a new network, one line to train the network by feeding in an array with inputs and outputs, and then one line to just run it and see what it predicts. And we're gonna together quickly train the neural network. This is an example that the person created for us, how to see contrast. So essentially, I think this has more contrast. In this case, I think here's more contrast. So I just, click a handful of times. And once the data set thinks it has learned enough about my preferences of what I think contrast means, I can then feed that array of kind of, inputs. Oh, sorry. Oops. Oh yeah, never mind. It ran. And now you can see, so here's some formula that essentially determines what contrast means. And then this is the result. And in both cases, white looks better on this example. In both cases, black looks better. So maybe 9 out of 10 times my network that I just trained in 10 seconds is as good as this generic formula to detect contrast. So that's kind of how easy it is. So the next step, I think I just want to, so the other thing I wanted to mention is data sets are hard to kind of come by, or rather it takes a lot of effort to clean up your data. For example, in the example of the image database, to make sure they're all exactly the same dimension. But there is a repository at the University of California, Irvine, that has 300 of such data sets. And I took one of them about housing prices. This is a bit old. This is like from the 80s. So the prices are, $25,000, $16,000 in the Boston area. And it has 12 different attributes, depending on crime rate, zoning, air quality, room size, age, et cetera, et cetera. And I took this data set and basically fed it into where is it? Here it is. Into a kind of library, into an algorithm that I wrote, or into a tool that I wrote. So the first thing, we're just going to create a really small training set because it takes a few seconds. So we're just going to have, essentially that data set that I just showed you has 506 entries. So I'm going to use 400 of those entries to train, and then I'm going to have about 100 or so available to kind of test it. Actually, at this point, I have to refresh the browser. Then I can load it from the database. Here's the one that I just ran, 5,000 iterations. So I'm going to select it. And then I can say, here are like my 500 or so entries. My 100 or so entries. And I can select one and test it. And then I can see, okay, my error is within 8%. I can test the second one. I'm like 1.5% off. And it's almost hard to believe, but they're all pretty close. Like there will be some that are above 10%. So here, for example, is one at 40% almost. But the majority, I think, is, even though I only just trained it with a really small kind of number of iterations, it's already pretty good at averaging the results. So kind of one thing that I had to do in order to use the data, let me just look back at the data for a second. The results, the numbers are all like arbitrary numbers. See, there's some numbers that are like in the 400s, etc. There's some numbers that are all 0. So the first thing that I really have to do is I have to clean it up. I have to make sure that all the numbers are between 0 and 1. So that's just like a quick function. As you saw maybe from the results, all the numbers were between 0 and 1. So I just look at every column, I find the min and the max, and I create a new range of my values between 0 and 1. And then the next thing is, like I kind of demonstrated, when I take that data set of 506 entries, I essentially divide it. Well, this is already old. This was yesterday. Today was already newer. But basically, I divide it so that I have part of the 500 entries I use to test it, and the other part I use to train it. And so, kind of my last slide. I know we only have 30 seconds left. Some tips to maybe save some of you some time. One thing is this library is very popular, but it's unmaintained, unfortunately. So there are a bunch of pull requests. People are also talking about just taking that open source library and just putting it into a new repo so other people can take care of it. So you might want to look into different libraries. There's one called convnet.js, which seems pretty well developed and pretty active. Also, there was a trick with Mongoose. So I actually wanted to store, as you could tell, I could store the actual results from the training set in my database. And there was a little trick that I had to actually tell the schema not to minimize data. So whenever an object is empty, which sometimes is the case with this, Mongoose would mess with it and it would, not come back the way that it was stored. So that was just like a little trick to be figured out. And with that, thank you very much. Are there any questions?